Good evening, friends. Welcome to today's webinar, and we will be discussing about survival analytics. Of course, I'll be explaining survival analytics theoretically, and then we'll see a case study that I will solve in Minitab, as well as a case study we will look into how to solve that using R. Now, to begin with, what exactly is survival analytics? Now, we have learned about logistic regression, haven't we? When do we resort to logistic regression, guys? Very good, very good. When Y is categorical, especially when it is binary, isn't it? Say for example, a patient is having cancer or not. An employee is going to resign or he is going to be loyal for the company. A customer moving out of the telecommunication network. And the most famous example, loan default. So a customer is going to default on the loan or not. Now, these are all the examples of logistic regression. But today we are not dealing with this logistic regression. Rather, we are going to go a step ahead and also understand when will the customer default. Right? So if I approve loan to the customer, he might be paying EMIs. Let's say he started paying his EMIs and he continued till, let's say, 20 months. And after this 20 months, the 21st month, this customer has defaulted. So this is what we are going to discuss, the survival analysis. When a customer is going to default, right? When is an employee going to resign? After how many months he is going to resign the company? After how many days or how many months a patient is going to die of cancer? Right? So these are the examples. Now, let's say if I have, let me take Vodafone or Airtel, I'm looking into the customer churn rate. Fine, this is all okay. Customer churn rate. I'm going to see whether the customers are going to move away from this network or stay with this network. But the critical point here is after how many months the customer is going to move away. Right? If I can upfront predict that, let's say after 3 months, a customer is going to move away from, let's say, Airtel to Jio after 3 months. If this is a pattern, then I can come up with some strategies, some plans, maybe 1 month plan, night internet plan, or whatever that is. Some strategies can be employed for these kind of customers to retain them. Why? Why you have to retain your customers? You can always get new customers, right? Why don't you fetch customers from Airtel to Jio or Jio to Airtel or Vodafone, whatever that is? The problem here is the main concern would be for any business enterprise or any business making unit. The main concern would be getting new customers is a very, very difficult task. Getting new customers, because you have to start looking into marketing campaigns, you have to do a lot of field surveys, you have to approach a lot of them, you have to be shameless in requesting them to become your customers, right? But if I can try and retain my customers, if I keep them happy, of course they are going to retain with me. If these customers give good feedback, that is half battle won. Because sorry, because of this good feedback, a lot of new customers will also look into my service now. Right? So retaining an existing customer is important, is less costly. because they are already associated with you, and you just have to make them comfortable with you. Now, where are various applications that we can apply the survival analysis? All these things are a few things that we are going to learn now. Now, survival analysis is also called as duration analysis, transition analysis, failure time analysis, or time to event analysis. You can give any name to this. Now, this survival analysis concept is applied in vast areas. A lot of domains use this. Few examples are posted here. Finance, loan performance, and this is this was the example that I've given. How is a customer behaving after taking the loan? Whether he is paying his EMIs on time or not, right? If they are defaulting, when they are defaulting, how are they defaulting, right? This is an example of finance sector. Economics. If I look into a business survival, I will be able to predict upfront, saying whether a firm, whether an organization is going to survive, right, and fight and make money, or is it going to get into a bankruptcy. Health of an organization is what we understand here. Time to retirement or finding a new job. Now, this is very, very important for governments. Now, if you look into the time to retirement, of course, you have to see the survival analysis, the same kind of analysis for different locations, different age groups, etc., etc. Demographics were considered when we look into time to retirement. And you can tweak your services so that you can keep them employed a little longer if their performance is better, or you can devise some strategies wherein these people who are retired can be kept occupied, right? Or maybe you can devise some strategy and understanding what kind of uh, uh, age group of people are residing in a particular place or particular area, right? So other benefits are also there when we do this kind of analysis. Now, finding a new job. We are looking into students graduated, and what is the time, how much time did they take in finding a job, right? So we look into this time interval, time to event analysis. Now, in this case, event is finding the job, right? Lesser this time, better the employment rate for that particular state. And if there is a huge time between graduation to finding a real-time job, then government organizations, government bodies might want to pitch it. They want to see on how to increase employment opportunities. That new strategies can be devised to help the young graduates. We can also look into, let's say, telecom industry that just now I have explained, customer churn rate, automobile industry, component failure behaviors can be looked into. A component is failing in a vehicle. Let's say there is a company Audi or Benz, whatever it is, right? Let's say we take components of these vehicles and we see the survival rate of these components after how many years or after how many days or months, whatever the time granularity is, after how much time these components are failing. Or if I have to put it in a different way, what is the health of these components? Duration. If I can upfront predict that by looking into the patterns, I can offer this component replacement when the vehicle is coming into service, rather than customers facing the issue while using the vehicle. I can replace that particular component when the vehicle is coming to the service and the time duration is very close to its failure. I can also extend this into looking into the component failures in multiple categories of vehicles. Right. So, for example, if I talk about Maruti Swift example, it has various models, various variants, right? Petrol vehicle, diesel vehicle, then again high-end model, mid-level, mid-section model, and within Maruti I have multiple models as well. Not only Swift, I have so many other things. So if I take a component, how is it surviving in all these different categories, all these variants? In which model the component is failing more? If we can understand that, then we can also analyze on why that component is failing in that particular model, right? What could be the problem? We can deep dive into that particular area. Right, so survival analysis is all about identifying when the event happens. Right, of course there is something called as censored observations. We'll look into that as and how we discuss. Now ultimately we are interested in how long, right, the event occurs, or what is the time duration for the event, survival rate, survival time. Now in this, when we do this analysis, we also get something called as hazard function, right? Risk of their failures. We'll look into this. Now these are various questions that can be solved, answered by survival analysis. What fraction of present customers will be loyal past a certain time? At what rate will the customer churn? Right, etc., etc. When will a customer buy a given product next? Right? So all this is part of your survival analysis. Now here we can also use the survival analysis to do descriptive analytics. So EDA. We'll understand the patterns, and then we can also plot, visualize these patterns and make inferences into certain business conditions. We can also segregate based on demographic groups, customer segments, of course, customer groups, sales channels. So I'm going to compare whether my, let's say, ads that are being published on internet are fetching me more leads, or do I get more leads via Facebook campaign, right? What is that marketing channel that I'm going to get more business? Similarly, sales also. In survival analysis, the most easy and most popular method is this Kaplan-Meier curves. There's something called as life tables. Of course, I can show you that in Google also. Life tables is talking about, let me just go to Google. I'll say life tables wiki. Is also called as mortality rate or actual rate. So if you look into this image, life table or for total population. This is for United States. This is an example. Between age 0 to 1, what is the probability of dying? What is the probability of surviving, etc., etc. If I know these kind of sorry, if I know this kind of information, if government organizations can get this kind of information, they can also look into what kind of strategies that can be employed if the mortality rate is high in infants. We can always do that, right? So what is the mortality rate between 20 to 30 years? So this is where a lot of workforce generates for a nation. Now if the survival rate is very weak here, then you know that there is next generation dying very soon. right? What is the reasons? Maybe suicidal cases, right? If you look into the maximum age, you'll also know what is the average age a person is going to survive, right? So using this, you can also look into your insurance policies. So insurance firms look at this. They decide what could be the premium based on the survival rate between these age groups. And based on that, they fix the premium. If there is a huge survival rate for this 66 to 67, or maybe from 60 to 67, the survival rate is very high. That means the death rate is very less in this age group. So there is no risk, less risk is there. So I can give the insurance premium at a low cost. So these are a few examples. Now, survival analysis is all about the survival times. That is nothing but time to event data. So if you see here, survival analysis is also called as duration analysis, transition analysis, failure time analysis, or time to event analysis, right? So let us understand that. Now, time to event means what is the time it needs, or what after what time the event is occurring, right? We are predicting time. So survival times are nothing but follow-up times from defined starting point to occurrence of a given event. Now example, beginning of a customer shift to churning. That means the customer is moving out of network. But here we have to look into the starting point. When did the customer join the network? Right? And this is the time duration that we want to do analysis. Then from here to churn rate, maybe this after 3 months, 0, 1, 2, 3. After 3 months, the customer has moved. So this is the time duration, time to event, which is 3 months. Similarly, issue of credit card to first default. So a customer is given a credit card for his transactions. He's doing the transactions all the while, and suddenly after 3 years, first time he has defaulted. So this 3 years would be the time to event. We are not looking into the incidences until the first event has occurred. Right? Insurance claims. So when did the policy was taken? After how much time duration the customer has claimed his first insurance. Now the problem is we'll not be able to apply logistic regression because the data that we are looking into is not the occurrence of event but the time duration of the event of occurrence, and this data will never be normally distributed, right? So we'll not be able to apply standard statistical techniques. And another condition that we have is called as censored. This is one of the reasons why we'll not be able to apply basic logics, basic statistical logic that we have learned. Now what exactly is censored? Censoring means incomplete observation. Okay, let me mute everyone. Give me a second. Yeah. Right. Censoring means incomplete observation of the time of event. What does this actually mean? Let me show you that. Now let's say I'll explain censorship or censored data using this example, where let's say we are analyzing patients who are suffering from cancer. Okay, there is a clinical trial wherein I'm doing the cancer patients analysis. How many days or how many months these are going to survive with the treatment that we are going to give. Now let's say we have begin the analysis here. Let's say this is January 2017. So here it is December 2017, Jan 18, Feb 18, March 18, and I have April. Let's say till April we have data or the time duration that we want to look into this study. Now, when we are doing this kind of analysis, each patient is going to be plotted on y-axis. Okay, and the time duration, it could be months, it could be days, it could be years, is plotted on x-axis, and each patient is, it's called a subject. In this example, I'm talking about cancer patients survival analysis. So each subject is one patient. Okay, this is in ordered fashion, of course. 1, 2, 3, 4, 5, 6, till I have 10 patients. I'm analyzing their what you call the time to their death, or how after how many days they have expired, or in other ways, if I have to use positive words, till how many months did a patient with cancer has survived, right? So this is the analysis that we are doing. Now the censored data will always be missing data. Censoring, right? Well, what does movies this Bollywood movies do? They censor, right? The certification body is censoring a lot of things from the Bollywood movies. That means they are editing it and removing it. That means we don't know what is there, what is that area. If you watch a movie, we don't know what is happening in that particular frame. It is totally eliminated. So I'm trying to give as simple examples as possible. Now, if you see the first patient, he has survived till 4 months. So that means when he entered the study, this was the time 1, 2, 3, 4. So in after 4 months he has died. So this is my time to event. This is my dependent variable. But if you see this subject 2, he initially enrolled into this clinical trial, into this study, but maybe due to some reasons, it could be various reasons, we don't know. Maybe he felt, as family members felt, that this is of no use. So he was requested to drop out of that study. So after 2 months, the person has dropped out of that particular study. So this, after 2 months, after this, I don't know what is happening to him. So this data is censored. Okay. Now there could be various reasons. As I told, he might have died due to accident. We don't know. Right? So there is no information about the subject after this 2nd month. Hence it is called as censored data. So this is again time to interval. This is also time. So time to event, time to event, time to event. So yeah, this is another example. Had a mortal domestic accident at 5 months. So he was very much part of the study, but due to some other reason he died. From here on, I do not have any information. Now this is also a censored data. That means the patient has survived all the while for our study. He is still surviving. But after this period, I don't know what has happened to him. Because I'm not looking into that case study, right? That subject. So this is also called as a censored data. Now there are various sensors. When you look into the sensor data, there could be three different kinds of sensor data. One is called as right censored, which is very much used for further analysis. There is something called as left censored. There is something called as interval censored. I think I have. Let me see if I have that. No, I don't have. All right. Fine. All right. Um, I wanted to show you something here. All right. Now, if you look into right sensor data, it is very much used for further analysis. Say, for example, in the same example, we are looking into doctors who are who are prescribing medicines for cancer patients. They are treating these patients. Now, if I know that a patient has survived all the while from time to start of the study till the end of that study, I've seen that the patient has survived and he is surviving even after the study. Then for other patients who have similar kind of attributes, I can say that these patients have a life expectancy of, let's say, 2 years. So with this kind of treatment, with these kind of geographical locations, gender, age group, I can segregate and say that if given this treatment, there is a high survival rate and the patients are going to survive till 2 years. High probability is there that they will survive beyond 2 years. Now, don't feel that doctors don't do the survival analysis. Doctors are very much doing the survival analysis that I just explained. So if you talk to any of your doctor friends, if you have, these doctors can explain that they were also being taught about the basic statistics. They'll also be aware of hypothesis. They will also be aware of regression. They will also be aware of survival analysis. Yeah, and using these studies only, they are going to predict what is the life expectancy of a cancer patient given a various conditions. Now we are looking into the characteristics of survival analysis. If you see dependent variable, this is nothing but waiting time or time to event. Now events can be positive or positive or negative, right? I'm talking about events. If you look into the cancer patient example, death is a bad event. It's a negative event. Person is dying. Of course, it is not good. But if you look into another example of employment for a graduate, after how much time he is getting a job, now this is definitely a positive event, right? So events will always uh, be dependent on the business scenario, whether it is positive or negative. And time to event, this time to event will always be positive. Okay, it cannot be negative. Time, right? It cannot be negative. Now, so I was talking about, sorry, the censored data. So the survival analysis that we are doing is to predict the time to event. We cannot apply logistic regression because we are in logistic regression, we are seeing whether the event occurs or do not occur. If you look into regression analysis, then we'll not have any censored data in that. We'll have complete information. So when you have censored data and when you have to predict time to event, we have to deal with survival analysis. And we also use the censored data for making a lot of other inferences. Just now I explained on how doctors use this. Now this is a typical example of how your dataset looks like. Again, the dependent variable is duration. This is your output variable, dependent variable that we need to predict. Next is event. Event is sorry. Event is your what you call the study that you're doing. Whether the patient is going to die or not, whether the customer is going to churn out or not, right, etc., etc. So here we are saying 1 for event if the event occurs. If a patient dies, that means it is 1. If patient is still surviving, is not died, then it is 0. That way. It's a binary data. Now, in censored data, we are also identifying the censored data in a binary format. So whether the data is censored, yes. That means we don't have data for this. After a certain point of time, we do not get any information from the subject. 0 means the subject is still under analysis. The event has not occurred, or event might have occurred. Now here we'll look into the hazard rate, and there is something called as survival function and hazard function. We'll not deep dive into this, but I'll just quickly explain the definition of these things. Now hazard rate is nothing but the probability that the event will occur at a given time t. Right? So all the while the event did not occur, and there is a chance that the event will occur at this time t. Right? And yeah, they change. If you look into the deaths of customers, patients, initially the patients will not die. When you look into the customer cancer patients analysis, initially the patients are not going to die. But as and how the time goes by, there will be a lot of death rate. Right? Another example is written here. Defaulting on the loan will be less at the initial stages. But as and how the time goes by, as and how the customers are paying EMIs, there might be a higher rate of defaults by the customers. Right? So hazard rates changes. Now these are the functions. I don't want to, as I told, I don't want to deep dive into this. I'll just describe about this. The dependent variable duration is assumed to have a continuous probability distribution. So again, we are discussing about probability distribution, guys. So we have integrals and all that. Now this f of t is called as probability of failure. Right? Now, if I have to look into survival, then it is exactly 1 minus this probability. Right? So surviving or failed. Hazard rate is a probability function that we get when we do this, and it is denoted as lambda. Okay, so yeah, we'll apply that in this example. Let's say I have duration here in months, assume this is months. And here I'm looking into, let's say, number of graduate students. Graduates. We want to see what is the employment rate here. So initially I have 100 people. So from month 1, 2, 3, all the while, all the students, all the graduates are they're part of the study, and they did not get any employment. At the end of the 3rd month, at this point, I found that 10 students have found job. So 10 of the people, 10 members have found employment, job offers. So this is number of events, DJ. And the number of censored observation means out of this 100, I also have 3 students who did not reply. So what I'm doing, I'm approaching all the 100 students, I'm writing an email and asking what happened after 3rd month. Did you get a job or not? So out of all of these 100, 10 people said yes, we received a job, and 3 people did not even respond it. Right? So if I have to give an example here, let's say in advanced countries, or for that example in our country, any state, let's say Bangalore, or let us talk about Pune. I have 100 unemployed people, and government is looking into the employment rate and all that, and it understood that 10 students or 10 people have got the job offers, but 3 did not respond. They did not even reply. Maybe they have moved out of Pune to Hyderabad or maybe Bangalore. They might have moved out, so they did not respond. So I, as a researcher, I don't have any information about these 3 people, right? So the function at here, hazard function, is nothing but dj by nj. This is the formula, where dj is the number of events and n is total. So if you look into this, hazard rate is, or hazard function is 0.1 probability, and survival function is 1 minus that. So survival function is 0.9. That means even after 3 months, there is still 90% of the people who did not get jobs. Yeah. So let's say after 3rd month, I'm now looking into 4th month. Next interval. So now my total number of subjects reduces because I have to remove 10 people who have got the jobs, and I also have to remove the censored data. I don't have any information about them, right? So I have now only 87 subjects. Now when I approached them, 3 people said yes, I have got the job, and 2 people did not respond. So hazard function is nothing but number of events by total, 3 by 87, this is the value, and survival function is, this is cumulative. So I'm going to take 0.9 multiplied by 1 minus this. The hazard function is like your failure, time to failure, or probability of failure. 1 minus that gives you the survival. So this, when you multiply, you get 0.87. That means after 4th month, there is 87% of the students still did not find any job. 5th month, I keep on doing this, right? And where is that? This is how. Okay, I don't think I have that image. This is another example that we have. So another example of employment. You can think of any function here, any example here. So I have in total 3,343. Number of events that occurred is 294, and censored data is 246. So this is survival function is nothing but 294 by 3343, right? Or I should say it is 1 minus this, 1 minus this. That is your survival function. When we do that, it is giving 91%. Then you have 87%. So that means after 1st month, there is 91% of unemployment. After 2nd month, 85%. After 3rd month, you have 81%. So on and so forth. After 28 months, even after 28 months, there is 31% of unemployment among these subjects. Right? So yeah, this is an example we are going to look into R, and this is how your graph looks like, your survival curve looks like. So the survival function shows that the survival probabilities go down to 31% at 28 months. That means there is still 31% of unemployment. Now if you observe here it is better, here it is getting normal, and here again it is better. getting steep death. Till here, the people were getting jobs in a better way. But at this period, the job offers were lean. Not many people did get the jobs. So we're trying and understanding what is this period? Why are people getting less jobs in this area, in this time duration? Yeah, maybe they are not considered as freshers or not considered as experienced people. In between, mid-level analysts, mid-level engineers are always right struggling to get jobs. That's what this survival curve also shows. You can also compare. Let's say I have two states. Okay, I have two states. I'm going to compare the employment policy of these two states in a country. Which state has better employment opportunities? Now, in this case, if you see, this curve is better because it is going down. So, as and how the time goes by, the more number of students, graduates are getting job placements, whereas this curve is having higher probability, maybe 40%. So 31% is always better than 40% in employment rate. Right, so this way we're going to compare the values. Let us also look into a few examples here. I'm going to show this. Yeah, so this is an example for drug addict, which was done in Australia in way back 2007. So here we are comparing two hospitals, assume two, what do you call them, rehabilitation centers. Which rehab is better? For people who are drug addict, they need to send to these rehabilitation centers, and we need to make sure that these are coming out of these drug addiction. So two clinics, they are being analyzed using various factors. Clinic 1 and 2, survival status, censored, departed from clinic is he has come out of the addiction. Survival in days, and yeah, maximum dosage is also given here. So clinic 1 and clinic 2, if you look at this, now in this case, clinic 2 is better when compared to clinic 1. Right? Because the event has changed, the analysis will also change, how we look at the curves. Because here I am able to retain the patients in my rehabilitation centers. But here there is a lot of churn rate from the patients. They are moving away. They are getting back to addiction. Right? And this is the exact impression that this curve gives us. After how many days? Right? We are able to retain, even after 1,000 days, customers are still retained with the rehabilitation centers. This is how you look into the data. Here we are also looking into the dose. How much dose did you get? This could be your dependent variable now. Now we are looking into identifying what is the dose of the medicine in mg that is keeping the people right surviving with this addiction. Right, they're not going back. If you observe, 80% is what 80 mg is what giving you the best result. So this is where you get the maximum percentage or probability, 641. So I can decide that I should be giving 80 mg as the drug. That is going to keep my patients, right? Keep my patients free from the addiction. So interpretation, the trend of higher survival rates at a high dose of around 80 is still observed in both the clinics. So plots reveal that around 80 mg the survival times of the patients were high, and this could be about the optimal dose. So from now on, decide that yes, this is the optimal dose that needs to be given for the drug addict patients, so that they retain with you. Right? Now let us look into a few case studies. Now here we are going to use Minitab, and after this we are going to look into R. Right. So here the example that we are seeing is how many patients have survived. Okay, this is the leukemia. This is basically called as blood cancer. Histio, I cannot pronounce that. Lymphomia is, I know. So it is blood cancer. So what is the survival rate of patients who are suffering from blood cancer? This is the data that is given, and the star values, the star marks that are provided means they are censored. Right? Now, if I look into this data set in Minitab, this is how it looks. This is this is my data. So time 6 months, 19 months, 32 months, 42 months, 43 months. So this is censored or not censored. 0 means censored, 1 means not censored. Okay, so that's what we have said. Thus, second column containing two values says 0 and 1. Yeah, fully observed data, and the 0 means censored data. Now, in order to do survival analysis, I have to do this. I have to go to this navigation. Let me show you here. Where is it? Where is it? Where is it? Yeah, stat reliability survival, and then here we are going with distribution analysis, right sensor data, non-parametric distribution analysis. So all the examples, all the tests that we are looking into are non-parametric tests. So initially it will not be anything here, will not have anything. We'll click C1, time, this is your dependent variable, and then sensor. Click on the sensor, and yeah, if you click on this area, it shows C2. Select that, and censored value is 0. We are saying 0 means censored value, right? If you are interpreted the other way, that means 1 means censored and 0 means non-censored, then of course the values will also change, and here we have to change 1. Right, so click OK. We are not giving any other parameter here. Also click OK. So this is my output. If you look into this, these are the probabilities that I get, and this is the curve. Of course, I have curve as well. And if you look into the curve, so initially I have 100%. This is the time. So all the patients were alive, but after a certain time there was a dip. So here I have, what is this? I think I forgot the number. Let me see. Let me look into that number. Yeah. So at 6, the probability is 94% survival. Right. So we are looking only into this time and survival probability. Okay, these are the two things that we require. So after 6 months, 94% of these patients are still surviving. After 19 months, 89 patients are still surviving. Like that, if you see, after 253 months, there is around 52% of the patients still surviving. Right? So this is how we make the interpretation. The same thing is shown in the graph as well. So time to event, and this is the survival rate. So as and how you come down, the probability is getting down. Right? So this is about Minitab. Let us look into R as well. Again, we are looking into that unemployment example here, where I have spell. Spell is nothing but the time, dry spell. Event is whether the employment is obtained or not, whether the person is getting employed or not. UI is it's like money given and unemployment allowance. So whether the unemployment allowance was given to that particular uh, the graduate or not, unemployed person or not. So all these are your different subjects. Here under time you have different subjects. I have 3,343 subjects. We have seen that, right? Example. So event is whether they are getting hired or not. UI UI is unemployment, and wage is the salary or the money that they are getting. We have log transformed it. There is no reason just to get a value here. We have log transformed it, and this is the respective age. Now using this data, we are going to now see survival analysis using R, and here we will apply this Kaplan-Meier survival analysis technique. So we know R is very easy. So the package is survival. So library of survival, and then let us read this data set into R. So let me navigate. So I have loaded this data set. I have 3,343 observations. I'm attaching that. I'm just redefining the variables here. Time is nothing but spell. Event is event. I'm creating another data frame or vector which consists of the other three variables. And I'm grouping UI. I'm saying group which consists of UI. And we can do summary. This gives you descriptive analytics. So what is the range, right? What is the median? What is the mean? All that you can identify using the survival analysis, descriptive analytics, like this. The function for survival analysis is serve fit. So we are executing it, and here we are saying time to event, survive, and the function we need to give the inputs of event and the time. You can do a question mark of survive fit to understand various attributes that are given as an option for this particular function. Now the result I have got is saved under KM survival, Kaplan-Meier survival analysis. So when I do summary of that, I get that probability information. So time to interval, it is ordered in descending order. So 28 months. Risk, this is the subjects. Events, and this is where I have survival probability or survival rate. So after 1 month, I have 91% survival. That means there are still 91% of the people unemployed. Like that, you can keep on deal with this, and after 28 months, I still have 31% of the people unemployed. We can also visualize this using this function, plot function. This is how it looks like. Of course, these dotted are for nothing but the confidence interval values. And if you observe, till here it was fine. Here the probability decrease is parallel to x-axis, almost very close to that, right? That means not many people have got jobs in this area at this particular time. But again, after some time, it was getting better. Again, after here, the churn rate, the employee unemployment rate is still strong. There are very less people who are getting employed after 20 months. So this is the inference interpretation that we do from the graph. We can also group them and then do a comparative analysis. So here I am grouping that output. Group is nothing but UI. I have grouped that UI. So I have group 0 and group 1. You observe here in the data set, I have this UI which consists of two values, either 0 or 1, which I have defined as group. I have declared that variable, right? So when I pass this, the survival analysis is a comparative analysis. And this is what your plot looks like. So group 0, group 1. So this is talking about unemployment allowance being given to the graduates or not given. Which curve is better? Right? And in this case, this is really bad. And if you observe overall, the second curve is always below the first curve. So here I have a better employment. Right? So this is group 0, group 1. All right. So this is survival analysis. Any questions, friends? See if few people have questions. Can combine regression and classification problem in some. Yes, that's what we have done, right, Hari? We have done clustering and excuse me, we have done clustering here. Of course, we have not exactly done clustering, but we are grouping using demographical details. You can apply a lot of other things as well. How to predict for a test subject in terms of months as prediction output. Sujit, I've not clearly understood your question. What do you mean by test subject? See, here we are only getting the probability. We will not be able to get individual value. Who did get the jobs? Who did not get the jobs? That information will not be able to identify in the survival analysis, but we will be able to identify the overall probability or percentage of employment in this example. Yes, Suresh, the session is getting updated into LMS as well. Okay. I have not done any classification. Okay, Hari, what does classification means? If I have a patient, okay, in this case a graduate, let's say graduate. If I say classification problem, I will be able to identify whether he is getting job, no job, business, etc., etc. I'm classifying into one of the class, one of the group, which is nothing but your output variable. But in survival analysis, we are not able to do that. Will not be able to do it. Will not be able to classify. Rather, we will say, what is the time duration of this event? Is it making sense, Hari? No, Suresh, no. You got it wrong. We are not talking about individuals. We are talking about the time duration. If you see here, I'm not talking about individuals. This is time and probability. That's it. Yeah, Suresh, got it? we will not be able to do a prediction using survival analysis. So classification combined with time forecast. Again, we cannot call this as forecasting because there will be a lot of sensor data. This is a different study altogether, Hari. You cannot combine it with anything. Can we identify survival function for multiple events? No. The probability. Hari. Yes. Probability is your output. That's what you get. Krishna, no. How can we predict time? We are not predicting time, Hari. Again, we are saying that out of all my subjects, the survival rate is this much for given this much of duration. So for 6 months, it is 94% survival. We are not predicting anything. Oh God. That is the input data, right? Hari, that's the input data that we have. Okay, let me show the data set as well once again. Oops, what happened? See, if you see my data set, it is time duration, and censored data or non-censored data. Okay, see, this is all. Again, I have to look into the data set and explain it. Let me show that in. Do you have it? So this is like failure event. You have seen that, right? Number at risk variable or failure variable. So how many have got the event? How many of them died? Or how many of them have survived? So that's the number of risk variable definition. Again, Harry, you cannot correlate anything here. I mean, you don't compare it that way, binary classification with time series. No. This is survival analysis. Okay. Maybe for your understanding, if you want to correlate that way, yes, fine, good. But yeah, you should not be explaining that survival analysis in this way. Even in interviews, don't do that. All right. Any further questions, guys? Indu, yes, if you have data, yes, we can do it. That's what we are comparing, right? If you observe the last image here, I was comparing to groups basically. I have two groups and I was comparing them. So if you have data, yes, why not? We can do that. Algorithm that I've used is survivefit, and this is obtained from this package called survival.
Hello.
Yes.
Is it Sharath? Yeah, it's me, Hari.
Yeah, Hari.
Actually, I was working on one of the car data set.
Okay.
if let's say I want to predict the garage analysis of the car, like I want to predict when the failure of the car occurs,
Hmm.
okay, based on the previous history.
Okay.
So it's more like a classification problem, multivariate classification combined with a time series forecast. You know,
Okay. So there you're
prediction.
predicting, right? Individual car. You're predicting individual cars.
Yes, yes.
Survival
So
analysis is
I
for
have a
talking about it.
time series. So I have a telematics data coming from a car,
Okay.
okay, and then it has about 40 columns and 10 lakh rows. So
Okay.
uh, I, if I wanted to know what is the time duration I have to set for the car to come in, based on that I need to schedule my jobs at the a machine shop, and what are the cars which I need to call in using the dashboard of for the customers. So these two data sets, how am I going to use this survival well, whether this fits in there or any other algo which you can suggest me, please?
Okay. So first thing is you're predicting. Sorry. You're predicting for individuals. So this
Yeah.
does not come into survival analysis. If you want to look into survival analysis in your example, then maybe based
Mm.
on the different models of cars, I can
Yeah.
understand what is the chance or which is the vehicle which has higher chance of getting into garage more quickly.
Yeah, that I can do. I mean, quickly, as in I can't do that. But then more risky, like based on the repair types it had from the last 2 years,
Hmm.
I can give you that data.
Okay.
Uh, if a vehicle vehicle X of registration number, and it has come for like 5 times in the last 2 years,
Hmm.
what is the chance that it can come within next 6 months, within next 3 months? How risky is it based on the classification of the repair types? If I say I have 30 kind of repair types, okay,
Okay. So this is
uh,
this is basic. This is basically going into multivariate forecasting models.
multivariate classif- multivariate classification combined with a time
Time
or something like
series.
IMA series. Yeah.
Yeah, yeah,
So how?
forecasting.
So I heard there is an algorithm for this. I don't know. I don't think this survival fits in that space.
Yeah,
So
yeah. This is not survival analysis case altogether.
yeah, yeah.
Okay.
So how can we deal with such?
Hari, I request you to send me the sample data and the business problem. So let me have a look
Sure.
at it. Unless until I look at the data and the scenarios of the problem description, I'll not
Yeah.
be able to comment. So please do send that.
Sure, sure.
I can have a look and then comment.
So I actually have some constraints with the business for the data, but then I
Of
can
course, yeah,
send a
you can.
sample of that.
Yeah, yeah, you can create a dummy
Yeah.
data.
Sure, I will do that for you. Can I have your mail ID, please?
It is Sharath at XLR. Just let me type in the chat
SH.
window.
Please do that.
Yeah, that
Yeah, I
type the
got it.
email ID in the chat window.
My name is Hari Krishna. I'm from Ireland
Ah,
as
okay.
of now. So I will be mailing you that.
Sure, sure,
Okay.
sure. Yeah. I'll let me have a look at and then I can respond.
Thank you, sir.
Yeah, no
Thank
problem.
you. Bye.
Rakesh, I have given you so many examples. Did you join late? I request you to go through the recording. In the beginning of the session, we have in detail explained various situations where we use survival analysis. Again, Narayana forecast is time series analysis. There we are looking into prediction. In survival analysis, we are not predicting anything. We are looking into, of course, we are predicting the probability, but here we are not predicting for an individual value. Yeah. Yeah, Rakesh, I request you to go through the recording once again. Yeah, once this gets updated into LMS, you can go through it. All right, guys. Let's call it the day for today. You can mail me, the contact details. If you have any queries, get in touch. Thank you so much. Have a nice day.